Hello everyone, this is a Priyanshu Chapter, Assistant Professor of Soil and Environment. Today we will talk about the soil air and soil air, how to influence a plant growth. So let's see what is a soil air. Uh, Soil physical property, one of the soil air is a very important part. The soil physical properties such as the texture, structure, porosity, bulk density, and the moisture content largely control the composition of soil air. Sandy soil have a low total porosity, but the size of pores is big, whereas the clay soils have high total porosity, but the size of the pores is small. The soil with bigger pores promote a rapid exchange of gases than a soil with a smaller pores. Therefore, the composition of soil are a many of change in sandy soil. The soils of a stable structure have a large volume of a micropores is 0.06 mm more than equivalent diameter and contain the amount of oxygen equivalent to its content in atmosphere. On the other hand, puddled or flooded soil are a high their carbon dioxide content due to a limited aeration. The reduction in the volume of a micropores upon a compaction leads to increase in carbon dioxide and decrease in oxygen. The restriction is diffusion of gas with increases in soil moisture, increase the concentration of carbon dioxide in wet soils in waterlogged soil. This is like sulfur H2S and methane and nitrate and may accumulate that have adverse effect on the plant roots since the surface soil diffuses directly with the atmosphere, therefore has a relatively higher oxygen as compared to subsoil. It is a causes the circulations of air in the soil. Respiration, the rate of respiration by a plant roots and microorganisms is the major cause increases of the variation in the concentration of oxygen and carbon dioxide in the soil, which is affected by the soil temperature, moisture, and type of soil organism. Soil organic matter and the biological activities, addition of manure, crop residues, sewage, slag, or other organic matter affect the composition of soil air to large extent during the process of microbial decomposition of these materials. The concentration of oxygen decrease and that of carbon dioxide increase. Next one is cropping. The growing plants tend to reduce oxygen and increases carbon dioxide concentration and due to a root respiration and the biological activity associated with the crops also tend to increase the concentration of carbon dioxide in the soil. Tillage, the exchangeable of gases and faster in tilled soil. Shallow tillage encourage carbon dioxide in the top soil in comparison to a deep village puddling required for a growing rice increases the micropods and the result in the poor irrigation for the succeeding crop like a wheat. Season the composition of the soil air changes with the season primarily due to change in the soil temperature and moisture. In a rainy season, soil have a lower oxygen and a higher carbon dioxide concentration as compared to summer when soil are dry and there is a better opportunity of gas exchange. But is warm season to a higher microbial activity. More carbon dioxide may be produced. The concentration of carbon dioxide increases the ranks because of increased decomposition of organic matter and slow gases. Soil aeration Soil aeration is the process of exchange of oxygen and carbon dioxide between a soil air and atmosphere. Soil air replenishes oxygen consumed and prevents accumulation of carbon dioxide involved depleted during the respiration of plant roots and microorganisms. Irrigation status of soil is usually characterized by the enriching process of gases exchange, the exchange of gases between an atmosphere, a renewable of a soil air. It is a natural process which involves two mechanisms, namely mass flow and diffusion. So, air movement in the soil. First one is mass flow. It means a response to pressure gradient, but a mass flow or of air occurs due to total pressure gradient of gases, which uh, causes movement of entire mass of area from the region of higher pressure to the region of lower pressure. Mass flow of air may occur from atmosphere to soil or vice versa and from an location to another in the soil. The difference in total pressure may arise due to a meteorological factor such as a temperature, pressure, wind, and the air replacement due to a and empiric temperature. First one is a temperature as per Charles' law. Air pressure is directly proportional to the air temperature at a constant volume. So whenever there is a temperature gradient between the 2 points, pressure gradient also develops, which causes gas to move. A temperature difference may arise within soil or between a soil and atmosphere. Therefore, a movement of air may be between the soil and or between a soil and atmosphere. Pressure as per boiler law, volume of air is inversely proportional to the pressure at constant temperature. With increase in pressure in the atmosphere, the volume of soil air decrease, resulting in a movement of air from atmosphere to soil. As the pressure in the atmosphere decreases, the volume of soil air increases, which causes the movement of soil air to atmosphere. Rainfall and irrigation displace the soil air as such to the lower depth when water is lost from the soil by evaporation, plant uptake or deep drainage, the air moves from atmosphere to soil. Wind presence and suction's effect of high wind causes the exchangeable of gases between the soil and the atmosphere, but the effect is restricted to surface soil only. Now, diffusion. Diffusion is response to concentration gradient and random molecular motions. Diffusion is the predominant process of soil aeration. In diffusion, individual gas constituents move separately due to partial pressure gradient, but the total pressure of air may be the same. When partial pressure of carbon dioxide in soil air increases due to root and molecular microbial activity, the carbon dioxide diffuses from soil to the atmosphere. Similarly, when oxygen in soil air is consumed for respiration, its partially pressure is reduced and the oxygen diffuses into the soil. Diffusion increases with increases in temperature. Fick's Fick's law of diffusion. It shows here as per Fick's law of diffusion, flux of a gas across the plane is proportional to the concentration gradient. Uh, Fick laws of diffusion here showing how F capital F is equal to minus T upon dc upon dx, where F is the flux of gas constituent in X is a direction. D is the diffusion coefficient. DC is a change in the concentrations and concentration in the small distance dx, and dc upon dx is the concentration gradient of the gas constituent. The flux gram centimeter square minute is inverse refers to the amount of gas diffusing in the unit time across a plan of a unit area. The equation of ideal gases is a PV is equal to small m RT, where P is the partial pressure of gas and V is the volume of gas and is the number of molecules of the gas. R is the gas constant 8.3 J inverse mole inverse and P is the absolute temperature. Therefore, N is N upon T is equal to C and P is upon RT, where C concentration. Substituting the value of C is K Q small q is equal minus T upon dx in bracket P upon RT is equal to minus T upon RT d small dp upon dx is equal to minus D d dash upon dp and dx. So where d dash are the constant, therefore d is a diffusion coefficient where the gradient is expressed in the terms of the partially presence of individual gas constituents. The coefficient of the diffusion of the gases depends on the texture, structure, and the moisture content of the soil. The rate of diffusion increases with the temperature. Under dry condition, the diffusion of gases is a higher in time than the coarser structures. Under moist condition, the behavior is reversed as the air pores will be more in the porous structure soil. Factor affecting soil aeration. So the volume of microspores after the total air and gases exchange in the soil. The volume of this porous largely depend on the texture, structure, degree of compaction, and the depth of soil. Due to a large volume of the microspores and porous structure, rich soils have adequate aeration than fine textured soil. Due to this, the concentration of carbon dioxide is higher in the fine textured soil. Puddled soil have a more carbon dioxide content due to a poor aeration, while aggregated soil may have some patches of a poor aeration due to the presence of compacted uh, soil layer. Topsoil soil are usually deficient in oxygen due to the reduced volume of nutrients. Soil aeration characters, characterization of soil aeration status. Soil aeration status may be characterized by determining the concentration of oxygen and carbon dioxide in the soil using chemical gases chromatographic method. The air-filled porosity and air permeability can also be used to determine the aeration status of soil. Other methods include the determination of diffusion coefficient of gas and redox potential of gas. However, the best method of characterized of the aeration is related to the measure of oxygen diffusion rate. In short form, we can say ODR. The ODR is the rate of which oxygen is replenished when it is used by plant roots or a microorganism. The ODR meter is used to measure ODR. The critical value of ODR of soil is 20 into 10 to the power minus 8 grams centimeter square minute inwards below which the growth roots of most plant is. The optimum ODR range for a most crop lies between 30 to 20 to the power minus 8 gram centimeter per meter minute inverse to 40 to 20 to the power minus 8 gram centimeter square minute inverse. The ODR decrease with moisture and the depth of soil. A soil condition where the ODR is the least 30 to 10 to the power minus 8 grams centimeter inverse the oxygen concentration of soil. Soil air is the least 10% in the root zone is considered as having adequate aeration. Management of a soil air aeration. The soil aeration can be optimized by managing soil structure, soil temperature, proper drainage plant adaptations, and regulations. Soil structure may be improved by addition of farmyard manure, crop residues, and the growing of the crops. Uh, in order to increase the volume of macros pores, the fine pores retain water longer time, inhibits oxygen diffusion, therefore necessary to avoid crusting and the soil compaction. Drainage, surface and subsurface drainage of field is essential for supply of sufficient oxygen where soil becomes saturated due to a continuous seepage from canals, pits, or a high water table. Heavy rain or irrigation, the drainage will decrease the moisture content and provide aerobic environment in the soil. Cultivation, a shallow shallow cultivation of soil and agriculture operation control the weed and help in exchange of gases, especially in properly trained heavy cultured soil after rain. If dust of is formed, may hinder the gases exchange. Light cultivation will help in improving soil irrigation. For the improvement of a soil irrigation is triple earlier planting included crops or soiling and the vertical mulching and the option of the organic residues into the cuts into the subsoil are very useful. Temperature and increase in the soil temperature decrease the oxygen diffusion rate, enhance the microbial activity can rise carbon dioxide production in the soil. The net result of increase in the soil temperature on the partial presence of the oxygen may therefore may be earlier positive and negative in such situations. Mulching applies an important role as a mulch protects the soil from the impact of the raindrops and therefore the helps in the retaining the till. This mulching facilitates irrigation, but it also keeps the soil moist and restricts the soil irrigation positive or negatively affected. The mulching on oxygen diffusion rate depends on the individual situation. However, it has been observed that the mulching usually decreases oxygen diffusion into the soil. Plants adopt Adaptations are plant adaptations plant root in general are adapted to aerobic conditions. However, some of the plant species develop mechanisms such as increases in the air space of root porosity or internal erosion through leaves and the cardiac cell and the grow well even in oxygen deficient soil. The selection of the crop species therefore is the important of for a growing crops in a waterlogged or a properly drained soil. For example, uh, thrives well submerged soil conditions. Soybean crops can tolerate temporarily waterlogged conditions better than a crop like maize, peasant pea, and other deep rooting crops. Regulations of root aspiration. Soil aeration may be managed via regulating respirations of roots and the microbes via fertilization culture practices, plant population and uh, incorporation of organic residues into the soil. Crops of a lower oxygen requirement or a shallow root system may be grown in situations where on the surface soil has some degree of fish. One of the most important method for measuring a soil irrigation is ODR. ODR, oxygen diffusion rate. So technique for a measurement of ODR, its principle when a certain electric potential is applied between a platinum electrode inserted into the soil and reference electrode oxygen is reduced at the platinum electrode surface. So the general reaction taking place at the platinum microelectrode surface in the reduction of oxygen is in two steps involving two electrons in each step. There are reactions in the two different media or in acid soil. In acid soil, oxygen plus two hydrogen ions plus electrons is equal to H2O. H2O plus two hydrogen ions plus two electrons so is equal to H. So oxygen were separate and the four hydrogens there and the four electrons there and two H2. In a neutral and alkaline soil, oxygen plus two H2O plus two electrons and H2O2 plus OH. Again H2O2 plus OH plus two electron is equal to two H2O. So oxygen and two H2O plus four electron and four hydrogens. An electric current flows between two electrodes and it is proportional to the rate of oxygen reduction. The rate of oxygen reduction is a term related to rate at which it is diffused the electrodes. The increases of current with potential continue until it is limited by the rate of which oxygen can diffuse from the oxygen environment to the electron. As to at the higher potential, the electric reaction rate is limited by a X factor and the current becomes somewhat independent of the potential. A second reaction starts at the potential of 0.7 to 0.8 volt. The second rise is achieved by a reduction of ionic hydrogens to molecular hydrogens because the current is up. Plateau reason is limited by a maximum rate at which oxygen can be used to the platinum microelectrode surface resulting. Difficulties measuring at the moment of the oxygen since general produce a using at platinum electrode to characterize soil oxygen status consist of harnessing a current which is proportional to oxygen diffusing through the electrode. It is necessary to consider diffuse theory is a order to complete understand what is actually being observed. Potential between a 0.55 and 0.75 volt can be used for a standard combination size of electrode. However, is also an important factor. So 25 gauges electrode usually gives accurate measurement of ODR value. So over the wide range of oxygen soil moisture, theoretically ODR increase with decreasing soil moisture. It has been also found that an increase in soil ODR as a moisture decreased to a point beyond which ODR decrease with the decreasing moisture content. This may be due to an incomplete electrode wetting excuses and concentration of sulfur in the soil very oftenly showed poisoning or what may be avoided by removing and letting the electrode in the soil. It is one of criteria generally used to determine the oxygen concentration in the soil pores space. It is consisted of allowing the free diffusion of oxygen into a diffusion chamber that was uh, inserted into the soil. The calculated partially pressure of oxygen at 10-minute and interval was used to evaluate the diffusion rate. The determines the rate at which oxygen can be replenished if it is used by respiring plant root or replaced by water. The ODR characterize the soil oxygen condition. There are the various factors that can influence the ODR, namely depth of the soil, temperature, moisture content, soil texture, etc. The ODR decreases with the depth of the soil, indicating that. With an increases in the depth, the concentration of oxygen decrease temperature affect the ODR by increasing soil rate of respiration and the diffusion coefficient of oxygen in water. The solubility of oxygen in the liquid phase is decreases. The ODR decrease as the moisture content uh, increases because of filling pores spaces with the moisture resulting space for a gaseous exchange. The ODR has come partially implications relationship between that plant root and soil moisture and the aeration status and biological activities in the soil, etc., which ultimately influence the plant growth by affecting various physical and chemical properties of the soil. It has been found that the root growth
Is a
easing
particular
when
importance
the
in
ODR
the
dropped to
absorption of
about
the water
20
and
gram
the
into
circulation
10
of
to the power
air.
minus 8
A
centimeter
desirable structure should have a higher
square
proportion of
per
medium size
minute.
aggregates and an prescribable number of and an appreciable number of the large pores through
Important
which
of
water
soil
and
air in
air
a
can
plant
move
growth and
structure
biological
of
activity
both
in soil.
the
So,
bioregion and
soil
the
aeration is an
erosion
important factor
is
in
a
a crop
very
production
crucial
for
to a
maximum
proper
production. Optimum
drainage in
levels of soil are must be maintained, and
infiltration
as
and
well as
productivity
plant
in soil
nutrient
with
and
a
what
poor
the
structure
plant
root
supply.
penetration in limited thus the
The gases constitute of
reducing
the
the
soil
plant's
atmosphere
access to
plays
water
a
and
vital role
nutrients.
in
Structure of the
modifying
A
the soil
horizon
physical,
has
chemical,
received
and
a great
biological
ideal,
environment,
a great
which
deal of
is turn influence
attention
the growth of
because
plant,
of the
enhance
its relation
yield
to
of crops. So the
seed bed
importance of the
preparation,
soil
B
aeration is
horizon
in irrigation
potential
to the soil
aeration, water
fertility and plant
infiltration,
responses are the
overall
generally
soil
avoided
health. So let's
divided
see
as
soil structure. The
like
primary soil
growth
particles do
of a
not
plant
exist
and
as
the
such.
development of roots. So the growth of
Um,
plants are adversely affected by
Such
a
in
poor
a
aeration, namely
natural
the
condition,
development of
but the
plant
broad
roots are
bonded
restricted or
together
inhibited.
into a
The
large units of
absorptions of
aggregates,
water and
usually
nutrient
termed
decreased.
as secondary particles.
The formation uh, of toxicity
These
substance,
aggregates
the
formed under a natural condition are called
encouraged by a poor aeration,
pads.
especially under a puddled waterlogged condition in case of
Where
rice
an
cultivation.
irregular shaped,
Adaptations of
coherent
plant,
mass
the
of soil
ability
formed
of
during a
different
tillage
plant
operation is called
species to grow
clod.
in soil with the low soil temperature, soil porosity varies greatly. Certain
Solid
plants, such
structure
as
is
a right that
defined as
are
the
adapted to
arrangement of a
growth
primary
without
and
an external
secondary
source of
soil
oxygen
particle in a
for the
certain
roots
structure
have a
pattern.
large
This
initial air
arrangement result
spaces.
in information of different
Plant adapted
sized
to poor
soil
aeration, so
pores. Therefore, a
shallow
soil
root system
structure may
in
also be
the
defined
upper
as the
part of
arrangement of the
the
various
soil where
sized
aeration
soil
is
pores
greatest.
in certain
The
structure
roots of
pattern.
plants adapted to growth
So now is the important of a soil structure.
in
Soil structure
irrigation soils
influence
have been
almost all the
found to
plant growth
carry
factors,
out
uh,
some
like water
anaerobic
supply,
respiration of
retention,
if oxygen is
aeration,
deficient.
availability of a
The effect
plant,
are
nutrient, heat, root
detrimental. The
penetration,
relatively low
microbial
rate and
activity, and
energy
etc.
output of
Strong
anaerobic respiration and
aggregations
accumulations of toxic product
decreases
are perhaps the most important reason. The compacted soil, the root penetration within the
decrease the detachability and
impressive layer and
transportability
restricted,
of
and the
soil
such
particles
restricted
by water and
root system are not
wind,
able to
and
absorb the
thus
sufficient
reduce the runoff
moisture and the
and
nutrient
soil
for the
erosion.
normal plant growth.
Soil
Microbial
structure is
population and
useful for a
activity. Soil
classification of
aeration influence the
soils.
activity
It
of
is
soil
affected by a
microorganisms
tillage,
and
cultivation, and application of
also affect
fertilizer,
the rate
manure,
of
lime, gypsum,
decomposition
and
of organic
irrigation.
matter. The poor soil
Classifications of
aeration
soil
decreases the
structure.
microbial activity as well as
Uh,
oxidation
Soil
of
structure is
organic
described
matter.
and
The
classified
decrease
based
may be
on
due to a
the
lack of
types
oxygen,
of
then with the excess of the
the
carbon
type as
dioxide, the
determined by
deficient
a shape
beneficial,
and
if the
arrangement.
different beneficial biological process carried out by a different microbial organism, such
The
as a
class as
decomposition
a
of organic
differentiated
matter,
by a size, and
biological
third one
nitrogen
is the
fixation,
grade as a
nitrification, etc., are
determined
largely
by
depends
a
upon the aeration status
distinctness
of the
and
soil.
the
Our aerobic
durability of
organisms are
beds.
unable to function properly
So
in the absence of
types of
oxygen in a
structure
soil.
based on
The
shape
microbial
and arrangement
population, therefore,
of a
is the
bed. Soil structure is classified
drastically
as a
affected
simple
by
and the compounds and simple structure,
drastically
natural
affected by a soil
cleavage,
aeration.
planes are absent.
Only the anaerobic and the fluctuative organism
Simple
functions
structure
properly
is
in a
of
poorly
two
aerated
types:
soil. This is possible owing
simple
the
granite and
area
massive.
ability to utilize the combinations combined oxygen,
In
and as a
single
result
granite structure, particles are
reduced
completely
from
unattached
forms
to
of a
each other,
different element
as
like
in case of
iron
a
and
loose sand.
mm, mm,
And while in massive
manages
structure, particles are the
iron
bonded
or
in a large
manganese
cohesion,
are produced as
structured
their toxic
mass in case
concentration
of
to
a
plant.
surface crust, plow, pane, and the clay
Production of
pan.
toxic
In
substance, heavy
compound
rainfall,
structure,
excessive irrigation or puddling together with flooding bearings about reduce the
In
condition of
compound
soil
structure,
or
natural cleavage
subsequently
planes are
reduction
visible
of
with a
element
naked
like
eyes.
iron and magnesium and
This
slow
shape
rate
are
or
individual
incompleted
pair
of
in
decomposition
described
of organic
according to
matter
relative
will
length and
take place
vertical
in the
and
soil, thus
horizon
the
axis
production
by
of
a
various
shape and
organic
their
toxic acid like
edges.
lactic
Compound
and
structure is
uh,
four
butyric and
types of depending
citric
upon a
acid,
shape
citric acid, etc. And also toxic
and their
concentration of iron and magnesium
characteristics like
are found
first one types of
in the
compound soil
anaerobic
structure and
soil
their
condition.
characteristics.
Absence
Type
of
1 is a
oxygen due to a production of such
blocky
toxic substance,
all
plant roots
the
get
shape
a
and characteristics
injury and
of a
thereby a
blocky.
lost
All the three
in
dimensional
their
of
ability to
pairs
absorb
are
nutrients and
of
water for
about
their
same
growth.
size, providing a
Absorption
shape
of
of a
water
block
and
having a
nutrients,
flat and
effects of
rounded face.
aeration on the
These
uptake
pairs are
of
further
nutrients by plants
divided
may
into
result
a
from
angular blocky and the subangular
changes
blocky.
in the nutrient
In the former
availability that occur
phase are flat
is
and the
in the
edges
soil
and
in
corner
response to
are
the
sharp,
aeration, or they may result
while
from
in the
changes
latter phase and the edges are mainly
in
rounded. The blocky
metabolic
structure
status
usually
of
found
soil. The
in a
plant,
B
the
horizon
mineralization
and
of nitrogen
promotes
is
good
generally
drainage,
not affected by the irrigation
aeration,
status of
and
the
root
soil. Various the
penetration.
availability of
Second one is a prismatic. The pads are analogate more in vertical than in a horizontal
the
direction.
availability of other nutrient element like phosphorus,
Given a
iron, magnesium
column-like shape,
are
vertical
increased
cleavage
by a poor
planes are
irrigation due to
the
flooding.
predominant.
The other micronutrient like copper, zinc show a
When the
deficiency
top
under a
of
poor
pads are
irrigation,
relatively
waterlogged
angular
conditions.
and flat is
Poor
called a
irrigation
prismatic.
decrease the uptake of water are evidenced by the
And when rounded, it
wilted
is
condition
called
of May
a
plant. After
columnar.
flooding, the permeability of root to water decrease under the condition poor aeration.
Prismatic structure commonly occurs in
Uh,
subsurface horizon
Incidence
in a
of a
arid and
disease, plant
semi-arid
roots
region
and soil borne disease organism
and
occupy the same environment and
poorly
respond in the
drained soil
characteristics
of a
way to a
humid
prevailing
region
conditions such
having
as the
a swelling
aeration. Change in the
type
aeration
of
may
clay.
modify the susceptibility of the plant. The
Platy horizontal
virulence
axis
of the
is a longer
organism
than
or
a
both,
vertical
so that
axis,
the disease
resulting in the
incidence
plate-like
may where with the
appearance.
conditions of the soil
Horizontal
areas may
cleavage planes
affected
are
of the aeration
predominant. When the pad
has to
are
do
thick,
mainly
they are
many the
called platy, and when thin
sensitivity
are
of the disease
called
organism and
laminar.
not
Platy structure is often
the plant cereals
inherited
or
from a parent material and may also be
moderately
formed due to a
tolerant to poor
compaction
aeration.
of a clay soil by a heavy machinery. Plate structure restricted infiltration and percolation and aeration soil. Spherical pits are roughly spherical and granular and subdivided into a granular and crumbs. Granular structure is less porous than the thumb due to a low organic matter content. Spherical structure formed by a biotic activity in surface horizon and promotes infiltration, percolation, aeration, and root penetration in soil. Classes of soil structure on the basis of size aggregates. Each type of soil structure is further subdivided into five classes. The size of aggregates is certain number of quantitative classifications of soil structure. Chorus and sand size aggregates are more favorable for plant growth and very smaller or very large aggregates. So grade of soil structure Grades of a soil structure. It is a qualitative means of the classification of soil structure. Qualitative means of classification of soil structure. Grades of soil structure are the identified on the basis of the stability of the grades. Stability of a grades refers to their resistance to dis- disruption by impact of raindrops under a submerged condition. It is influenced by a moisture content amount and type of clay and nature of the adsorbed cation and organic matter content of a soil. High moisture content, colonite clay, developed cations and high organic matter content make the aggregates relatively soft. Three structure grades have been identified as a weak, moderate, and strong. So, grades of soil structure. To describe to soil structure, the sequence, grade, class, and type of the followed for example: strong, porous, angular, blocky, moderate, thin, platy, and weak, fine, prismatic structure. Like a great weak, first one is weak, so characteristics are poorly formed, indistinct pads with which are not as stable. Moderately developed pads which are fairly stable and distinct. A strong, a very well developed pad which are quite stable and distinct. So genesis of structure refers to the uh, cases and method of formation of aggregates. The following two processes are the involved in the genesis of structure. First one is a flocculation. Flocculation. Flocculation, it is an electrokinetic phenomena is in which positive and negative charge are involved in a soil water suspension, and the clay particles with a high zeta potential repel each other. With the addition of flocculating agent, zeta potential is lowered. The particles come closer and attract each other, resulting in the formation of floccles of silt size. Floccles are stable as long as the flocculating agent is present. Flocculations also take place due to hydration, high soluble salt concentration, and the presence of the divalent or trivalent cations. Cementation of floccles. It refers to consolidation of a clay foccolates by a cementing material so that they may not get displaced once these have been flocculate, as floccolates are not large than a silt size. Therefore, flocculations would be unfavorable for a plant unless these are further aggregates by inorganic calcium carbonate oxides of iron and aluminium and organic matter cementing. materials. Flocculation of a clay particles is therefore the request for aggregation. So aggregation is always refers to a flocculation plus where a plus in the cementing agent. Factors influence the formation and the stability of the soil structure. So first one is the physical factors. Physical factors includes the wetting and drying and freezing and thawing. Alternate wetting and drying leads to a formation of a smaller aggregates, particularly in the fine texture soil. Drying causes a shrinkage of the soil mass, and when the large dry cloud is wetted, rapid entry of water causes unequal swelling in the cloud, and the cloud is fragmented along the cleavage plane. In the process of wetting, increasing the pressure of the interrupt air cases distribution of the large cloud into a smaller pieces. Similarly, freezing cases cracks in the large plot by expressions of a water. These cracks cracks takes in a more water upon thawing and get enlarged further of the refreezing. Chemical factor. The chemical factors includes the exchangeable cation and the binding materials. Clay acts as a cementing agents, also swells shrinkage upon the wetting and drying. In certain also small aggregates are held together by a covering of the clay particles. Exchangeable ions such as the calcium, magnesium and potassium have a fluctuations effect on the clay, while sodium has a dispersing effect. The sodium ions are dominating on a exchangeable complex of a sodic soil cause particles or repel each other and hinder the formation of the aggregates. The divalent cations such as the calcium and magnesium causes the individual colloidal particles to come together and form foccolates. Calcium also help in binding the organic colloids and clay particles. Hydrate swaxe oxide from almost completely inversible colloid upon dehydration and the uh, and help in forming stable aggregates as in the lateric soil, oxysol and ulti soil called the lateric soil of the humid tropics. So Swaxy oxides also formed a complex with a humus and calcium carbonate precipitating around soil particles act as the cementing materials for aggregates and imparts a stability to soil aggregates. A soluble salt and to enhance the flocculation of the clay even in the sodium saturated clays. Organic compounds play a key role in aggregation and stabilization of soil structure. Fat, wax, lignin, protein, raising, etc. also help stabilizing the soil aggregates. Humans help in the aggregation by the forming clay humus complex. Only a calcium humus is a focculating due its tendency of a from a complex with the organic compounds through the the coordinations linkage the magnesium, potassium and hydrogen and sodium humus is defocculated and does not help in aggregation synthetic soil conditions. Long carbon chain organic compounds are also used for soil aggregation. These compounds attach time wells to the inner exchange sites of the clay and the bind the clay particles together at addition of these compounds in relatively small amounts and can produce a good structure even a sandy soil. Biological effects, biological factors. Biological factors, the plants and plant residues help the soil particles to bind together. Um Gelinations, organic compounds extruded from a root binds and soil particles together. Root hairs penetrate soil clots to create a point of the weakness and ultimately break the clot into aggregates. This also helps the soil particles stick together in a granular form. Plant residues serve as a food for microbes, which play a prime role in the aggregates formation and the produce sticky substance or decompositions. Microorganisms decompose plant and animal residues form a humus, and this humus binds the particles together. Algae, fungi, actinomycetes, and bacteria, which continue the living matter in a soil bind. Soil particles more effectively than the exchangeable ions. The small animal like rodents, earthworm, spiders, mites, nematodes, insect, centipedes, and millipedes, etc. Uh, Facilitate the formation of soil aggregates by way of borrowing, turning the soil, or throughoutly. Mixing the organic residues with the soil. Evaluation of a soil structure. The soil structure can be evaluated both of a direct and indirect method. A indirect method soil structure is characterized by the observing the shape, size, and arrangement of the soil aggregates either or a microscopically and microscopically. In microscopic technique, thin soil section are examined under various types of microscope for shape and size of aggregates and voids. For microscopic evaluation, are large soil clouds in clouds. It's excavated from the field and allowed to fall gently on a smooth surface, which breaks into pads of a different size and shape. Shape and size can also be observed directly from the cleavage of the pads in the soil profile. Indirect method involves a measurement of the size distribution of stable aggregates, stability of aggregates of the soil property, which is the function of soil structure. Soil is indirect method, size distribution of stable aggregates. So, dry or wet sheaving techniques are used for determination of different size stable uh, aggregates. In direct dry sheaving techniques, the proportion of a stable aggregates against a vibrating action stimulating of the scoring effect of wind is determined, which the provides and the index for a characterizing the susceptibility of soil to wind erosion. In wet Shaping technique, size, distribution of water stable aggregates in a determined measurement of the stability of aggregates. It is evaluated by the degree of the which soil aggregate resist dispersion. Several indicates have been developed, such as the stability index, structure coefficient, and dispersion coefficient. Stability index and is the difference between a percentage silt and clay as determined by the mechanical analysis and that the obtained by suspension of soil sample in water. The great the difference, the better in the soil structure. Structure coefficient is given by uh, d minus s upon s, where d is a percentage of particles less than 0.25 mm in diameter as determined by the mechanical analysis, and the s is the percentage of the aggregates smaller than 0.025 mm in diameter as determined by the wet sieving method. High the value of the structural coefficient, the better is the soil structure. Measurement of the soil properties: bulk density, infiltration rate, hydraulic conductivity, aeration, available soil water, degree of compaction of soil may be used for evaluation of soil structure. So indicates of a soil structure: amount of a different size soil aggregates is represented by the single value of the comparing the structural status of different soil or the same soil under different management particles. Among the various indicates mean a weight diameter of the aggregates is a commonly used index of soil structure. The mean weight or diameter of aggregates gives an estimate of a weighted a percentage of the average size of all the aggregates. The proportion by weight of the given size friction of the aggregates to the total sample weight is a multiplied by the mean diameter of the that frictions. The sum of these products for the all size frictions gives a mean weight diameter of aggregates in a mm. uh, Management of a soil structure. So the general practices for improvement of the maintenance of the soil structure: tillage operation be carried out within the range of the optimum moisture condition to ensure least destruction of the soil aggregate. Zero and minimum tillage practices be adopted to maintain adequate aeration and reduce the loss of organic matter through oxidation of or erosion. Soil surface be kept covered with the crop residues to protect aggregates from the beating action of raindrops. Check weed emergence and add organic matter. Incorporation of the crop residues and the manures into the soil for the stabilizing aggregates. Introduction of legumes in crop rotation coupled with the application of the phosphatic fertilizer. Green manuring and cover crops are a good source of organic matter. Integrated use of organics and fertilizer for crop productions. Some soil have a specific structural problem which need a proper soil management practices for a better soil structure. Sandy soil. This soil have a problem of low water and nutrient retention. The practical method of improve structure of the soil, such as soils, is to add organic matter directly or through a green manuring. The addition of the pond sediments, can clay soil, or even a compaction is helpful in increasing the proportion of small size pores for the enhancing uh, water and nutrient retention capacity. Clay soil, these soils have a restricted drainage and the aeration due to a poor aggregations. Addition of a soil matter through a helpful for improving aggregation, but the required amount is high. Therefore a crop rotation and use of phosphatic fertilizers are useful. Raised or raised bed cultivation can reduce the aeration stress problem to some extent. um, Puddled condition in areas under a prolonged waterlogging, the soil aggregations are broken, leaching to puddled condition, poor drainage, and possible solution of a soil problem. Disparate condition, the problem of dispersion is found in a sodic soil.